Uh, Good afternoon, participants. Uh, Today, I do not have much to show because if Ananda and Abhijit has shown us most important things. Probably I have little here and there to share with you. Uh, okay. Am I audible and can my is my screen visible?
Yes, yes.
Okay. Okay. So today, my topic was file handling by NumPy and rudimentary statistics. But file handling has already been dealt with by Vijit, but I'll just repeat it once again. There is no harm if I repeat it. Say, I think my fonts are visible, or should I increase the font size? This is okay, or should I increase the font size?
To me, it is okay, but I don't
Fine,
know.
on laptop it's okay. Check the on mobile.
Okay, okay.
People
So
on mobile might have a bit of
okay.
yeah. This should be okay.
So today my first problem is that say I have a file like this which has two column data, say containing maximum temperature in Fahrenheit of a city on successive days. And my task is to read the file, convert the temperature into Celsius and plot. Okay. So we know how to do this. We will create a first import NumPy as the NP, and because we are going to plot, we have to have a matplotlib, and then we will read np.loadText is the comment. And if we have to do it in a notebook, this R is important because otherwise this /u/a etc. The notebook will try to interpret as some Unicode command, and it will say that nothing is understandable. So just tell the notebook that there is nothing new, Unicode. It is just a raw command. It's a name. So let's run that, right? Run that. We will see whether it has been able to has been able to read this data. Now the next point would be to fraction out the days and the temperature. That is the first column and the second column. And we have already known we already know how to do this. We have to this is the way to denote the first column. Colon comma 0 is the first column, and colon comma 1 is the second column, where assigning to D and TF, and the TC, temperature in Celsius. Just I write the formula, and because it's an NumPy array, it's a vectorized operation. Everything will be converted to that, and if I do a plot, I can the TC created where every temperature is now converted to Fahrenheit, Celsius, and now I can plot. Gives me a plot. Okay. And now, if I want to save these file, this day and the Celsius temperature plot in a file, then what should we do? There are many ways to do it. My favorite way is first convert this day, this one when is kept in is a one-dimensional array. This is also a one-dimensional array, but I want to make sure that this day is a column matrix. That is, it has 10 rows and one column. So I just did that by d equal to d reshape 8 1. So it's why it is 8? Probably it was 8. Yeah, some 8 rows and one column. So it's a column. Let's see how it looks like. If I say give D after reshape, also it doesn't show the proper. Okay.
No, you need 1,8 for what you want to do, I guess.
No, I want 8 rows and one column. 8 rows and 8. I don't know why it is. Anyway, purpose will be served in any case. So now what I do is I stack them side by side. this T and D and TC. I stacked them side by side. So two columns are stacked side by side, and then I save them in a file. The whole stack, the two column things is kept as aim, and I save these aim in the file temp1.txt. Let's do that. Let us first check that this is in the download directory. There is no such file called temp, and now I run this. Let's check. Sort by date modified. Downloads. Sort by date modified. Yeah, temp is created. I can, if you, oh, sorry. Control plus. Although I created, but it's not the right kind of array, it seems. Let me see what, how does aim look like? Aim is not the right thing, is it? What happened, the problem? Oh, I think reshape is not proper.
You need a tuple there.
Yeah. Like this one, huh?
Yeah.
Yeah.
Yeah, inside that.
Yeah. Okay. Yeah. Syntax error, why?
No, there will be another bracket at first line.
Huh? Oh, I see. Thank you.
First line.
Thank you. No, it doesn't.
So why are you trying to
D is
restart that?
okay. D is okay.
Yeah. We should have worked with 8,1 as well. I don't see why not.
Why?
It usually works with both of them. No, but D dot reshape, the problem with D dot reshape is that it does not produce a new array.
I know.
It returns. So
Produce
you need
it.
D equal to.
Why I did that. Okay. Now they should be in the proper condition. Why not?
Dot stack. You have to rename it.
I don't know why. This is used. Now I can. So they are 8 stacked side by side. Now I can save them here. First, delete this file. Delete this file.
Arunabha, show me again what happened. I missed it. What happened? Problem?
I don't know. I did the mistake. Instead of this tuple, I just write 8,1. That was a mistake.
Also works without tuple.
No, it usually works even without the tuple. I don't see
it
why
also works without tuple.
it assumes it's a tuple anyway.
Yeah, sometimes strange thing happens. Okay.
Yeah. Anyway, this is created, and now I can save it. Run, save, and yeah, temp1 file is created. No, let me delete this temp1 file. Oh, this is not saved at all. Look.
What I was thinking.
Yeah, I think now it will be working. Temp1, yeah, 2 column file. If you can see, 2-column file is created. So the point is, I have read the file, I have converted the data, plotted it, and now saved it as a different file. Okay. Now, my second problem. Let's have a data file which contains marks in 5 subjects of 10 students. Let us see the file. How does it look like? Okay. So it is pi case demo marks 2. So if you can see this, this is a file which contains the first row says, say it is R is something, A, B, C, D, E, F, G, H are the names of some students, and the subjects, physics, chemistry, mathematics, engineering, environmental science, and the marks are given over here. So I have to read this file. So first I do what I naively, I want to try this one. Load the one that I learned so far. So just the file name and load text. Run. It gives me error. And the error is obvious because there are some the quantity like R in the beginning of the file, which it obviously cannot convert into a float. So I have to get some way out. And that is it. Let's see. The same command, but with some extension. Skip rows equal to 1, so that I can ask it to skip the entire first row. And the second thing is I would like to skip the first column also. Here the point is use calls. Which columns are to be used? Here I said NP arrange 1 to 6. 1 definitely is the 2 in the colloquial language because index 1, and 6 means I have to stop before 6. So it is 2, 3, 4, 5. 1, 2, 3, 4, 5. These columns, 5 subjects, I have to find out. So that's it. Run this. What's the problem? Oh. I have to check this out. Yeah. See, now I can read this data. Even with this R and these strings, I can avoid them. I can read the slice of the file which I want. That is the point. If the file is even big, I can read the slice of the file that I want to read. So I have read this file. Now these are the marks. Each column stands for the marks and each row stands for the students. Therefore, each row, this is a mark sheet of a student.
It skipped A, B, C, D also, no? The first column. It
because I said use columns.
Oh, yes.
1 to 6. Instead of 0, I said 1, so it avoids the first row. So I got only the float things. But the point is that we can do load text if we write that some columns will have, say, float numbers, some columns will have strings, some columns. We can also specify those formats in the load text. Load text has many options. I can specify that some of the columns will be strings, some of the columns will be float, etc. I mean, it's very flexible.
So we can check it inside what it is there.
I can, but the point is that one column has to be a similar kind of thing. If it is all entries in a particular column has to be similar. That I can specify. Okay. Now that I got the matrix, the point is that this one is a mark sheet of a student. On the other hand, each column I can understand as a tabulation sheet of a teacher. So the point is that one student may like to know what is the average number that he got. On the other hand, a teacher would like to know what is the average number scored in physics. That is the average of this or the average of this. So we have to get both of them. So first of all, say, let's say average is, I give this column, say, first of all, see, this is np.mean is definitely mean. Okay, I stored that in average is for whatever, and I here say 0 designate by 0 axis. So this is my 0 axis. I So therefore, I'm averaging over the tabulation sheet of the each teacher. So there are 5 subjects. I should get 5 average numbers. Okay. So first, let us hash this out. I don't want this either. So this is this. Oh, because it is not saved.
Yeah, the M was something else. Now you save it.
Yeah. M is not saved. Now this will do. See, I have got 5 numbers. These 5 numbers are actually let me see. If I average of this column, this column, this column, this, so average of each tabulation sheet. But definitely, I would like also want to do the other way down. The average of the mark share, each student's average. So that will be averaging over the axis 1. Averaging over the axis 1. So now I have so many entries. Each entry is the average of a particular student. Each entry is the average of a particular student. So that's clear. I can do that. Average over 1, average over 2. I want to do the standard deviations also. Standard deviations of 0 and 1. I can do, so that will be standard deviation along 0, standard deviation along 1. Average is STDS, that gives me standard deviation along therefore these are the standard deviation. So these are the mean of each column and the standard deviation of each column. This is 5 means and 5 standard deviations. Now let us calculate the Z score for each subject of each student. What is Z score? Z score is that from the marks of each student, I have to deduce the average marks in that subject and divide it by the standard deviation of marks in this subject. Let me go to this file. Say this is the file, and I want, instead of the raw marks, if I want to replace them by the Z score, what I have to do, first of all, for physics, I have calculated the average of physics, average marks in physics, and standard deviation of marks in physics. So each of these marks I have to deduce the average marks of physics. In this column, each entry I have to deduce the average marks of physics and divide the standard deviation of marks of the physics. Therefore, I get the Z score in physics. And the similar thing I have to do for the chemistry, for math, physics, etc. Now here the problem is that I have to deduce each column by a particular number, and second column by another particular number, third column by another number, and divide this column by some number, divide this column by the other number, and so on and so forth. So apparently the problem looks like that without going to explicit loops, it is difficult for me to do that. So let me see a trick first. This is an array, a 2-dimensional array. Let's see what it is. It is 32, 33, 42, 45. And what is this? What is this? P. P is 10 and 5, definitely. And definitely it's a first one is a 2x2 matrix, second one is a 1x2 matrix. Definitely if I write A minus B, that will be a wrong thing. I cannot do this subtraction. But there is something called simultaneous broadcasting. I think, I don't know, Anando has given a note, perhaps that contains a detail about simultaneous broadcasting. That's a complicated thing. But here, in this case, the take-home rule would be that, I mean, otherwise it is not doable, but if you still ask it to do, then one of the dimension matches. It is 2x2, this is 1x2. So the one matches the other dimension which doesn't match, it will copy the same thing. So that means that if you ask it to do A minus B, so A is clear, B is just 1 by 2, just one row. It will copy the row twice, so it will make a matrix of 10, 5, 10, 5, and then do the division. And if I do that, then I get my exact result, the one that I wanted, for example. See, so from each of this row, 32 and 42, I'm just reducing reducing to 10, and from 33 and 55, 52, I'm reducing 5. So I can do that by simple trick. So I apply that for the original matrix, and I reduce the average of x and standard deviation of x, and that gives me the z scores. So this is one of the things that I can do. And the second thing is, if I want to know, ask the question that whether there is some sort of correlation between the numbers, like doing good in physics, has any connection with doing good in mathematics or so. But from the data, is it apparent? Is there any correlation kind of thing? So the first thing that I tried here is to find the covariance matrix. Normally, if we do the covariance, it will calculate the variances of the rows. The correlation between the, it will try to find out the correlation between the rows, which I don't want. I want the correlation between the columns. So I set covar equal to false. If you don't give this, then it will try to find out the correlation between the rows. So I said covar equal to false. So it will find me the correlation between the columns. And if I do that, see, I get this covariance matrix where the diagonal elements are the variance of the variance of each column, and the non-diagonal elements are important. For example, here I can see the 1, 3 element has got a very high value, which means they are very positively correlated. Let me see the file. See, 1 is physics and 3 is mathematics. And if you can look at this table, then you know that going good in physics is correlated with doing good in mathematics. Somebody who fails gets very poor number in physics, also gets poor number in for mathematics, and those are, so there's a positive correlation which is reflected over here, and there's a second this correlation is 171. That is 1, 2, 3, 4. So 1, 2, 3, 4 means physics with English is also very correlated. So the point is, I can do all sorts of things by doing simple such things. Now I want to show you something else. Okay. First of all, let me generate a random integer, 10 integer. Random integer from 0 to. Oh. So what it is? What is the? So it clearly shows that it generates a random integer between 0 to 10. It has a 0 but not 10. So it starts from 0, doesn't touch 10. Random integers and 30 integers are generated. Okay. Now I can keep it as x and do different things like, as we know that if we want to say do a cumulative summation. Cumulative summation means I want to generate an array where the first element will be 4, the second element will be 4 plus 7, the third element will be 4 plus 7 plus 3, and etc. So what I have to do, np dot cum sum of x. No, something wrong. The first element was x is something like this. Okay. And then do over here. Let's create a insert cell above. Yeah. Now here, got np dot sum of x. Now you can see I've achieved my goal. First element is 1, second element is 1 plus 3, 4, third element is 1 plus 3 plus 5. That is how I can generate the cumulative sum. On the other hand, the other thing, if I want to say, for example, get an array where the first element is the difference of 3 and 1, second element is the difference of 3 and 5, etc. All I have to do is to give diff. Say 3 minus 1 is 2, 5 minus 3 is 2, 4 minus 5 is minus 1. That is why that is how I can generate it. And now two more interesting thing, that np.max is obviously the maximum of this 9. Maximum of 9 fortunately occurs only where? Only at one place. And now I just want to know at which place it is. Argmax. I want to know the index of the point. It simply says argmax. Okay, so it's that way simple. Position of the maximum. Argmin, mean and argmin also works that way. Now, what is this? What is this, first of all? Anybody can guess. I mean, what is this going to produce if I do this? I asked, look at this and let me see if somebody can answer this. I mean, if you can, I mean, I cannot see the screen. I mean, just unmute and answer what this is going to produce. Any idea what this is going to produce?
So they saw this yesterday, I guess, but not yesterday, day before yesterday.
Do not, Ananda, don't tell me, please, for the participants.
Well, unmute and please say it out loud, because Arunabha cannot see.
Yeah. If I want to see your screen, then this will be lost. So I just don't want that. I want to keep it open for you, and that is why you have to unmute and tell me.
One person has already answered, but it has to be answered out loud.
Okay, just tell me. Unmute and tell me. I can't hear, please. Abhijit, Ananda, tell me the answer.
Okay. What has been said is the average of 3 consecutive numbers.
Yeah, it is called rolling average. It is called rolling average.
Yeah.
It is called rolling average. You know, usually, I mean, in many cases, you see where there's a very noisy data and we want to smooth it out. You always do it. That just you replace the average of 135 by the first number, and then 354 by the second number, the average of 543 by the next entry. So we take 3 consecutive numbers and then average out and generate a data. It's called 3-point rolling average. And in the context of COVID, people are showing different kinds of graphs, and people are many times they're showing that this is a 3-point rolling average or 5-point rolling average of the growth curve or the death curve, whatever. So the doing this kind of thing is actually very easy. Yeah, the rolling average. Okay. Now I want to show you that. I mean, I don't want to detail out more about statistics, but I want to show you that Sci-Fi is another module of Python which has many interesting many interesting functions relevant for statistics. So those who will be interested in doing that, I mean, just explore. I mean, half of this I don't understand, but there are many things. For example, the descriptive statistics, which gives all sort of mean, median, etc., skewness, kurtosis, etc., can be found out, mode, etc., etc., and then one way, ANOVA, and then t-test. Everything is there in the statistics package. You just explore if you are interested in. And then I also show you something. Okay. Next, the topic that I have to talk about is Sci-Fi. I won't talk about Sci-Fi, but show you what Sci-Fi, the huge library that Sci-Fi has. See, Sci-Fi has a huge library collection. There are also subdivided into many folders. Like this one is integration, that contains many integration functions. Like Anando has already talked about some of them: the Simpson integration, trapezoidal integration, quad, which is an adaptive Gaussian quadrature, etc. Many things, and there again different optimization technique. I will use some of them. Just scarf. I'll use one of them. Curve fit, and then interpolation, Fourier transform, signal processing, linear algebra, sparse eigenvalue, etc. I mean, it's really a huge library, and it doesn't make sense to it doesn't make much sense to read the dictionary as such. Whenever you need it, you consult it. So you have a particular task, you just say whether this is already there in the Sci-Fi. So that's it. So now there is something which I want to show you again a little bit. Insert cell above. Regarding, there is a folder in NumPy called linear algebra or linalg that can help us to do something. For example, so some tricks like a equal to, say, np.array. Let's give a matrix. Huh? So I think it's a two-dimensional 3x3 array. Okay, and let's say, how does A look like? It's a three-dimensional array. Okay. Now I say A dot P. Please look at it. 1, 2, 3 was the first row. So, and A dot T would be just the transpose. So doing the transpose need just A dot T. And now if I want to get the, say, determinant or the trace of the matrix, what I have to do, there is a np dot linalg is a submodule. Within submodule there are many functions like det of A. That will give me the determinant of this, and then trace. Sorry, it's not trace. A dot trace. I forgot. Okay, I have to find out. Anyway, one can always find out.
Trace function. Trace. A dot trace. It will work. A dot trace work. Or np dot trace inside A will also work.
A dot trace. This one. A dot trace.
Yes.
A dot trace. Yeah. Fine. And then the point is, say, np dot linalg dot eigen na eig eig of a,
Yeah.
eig of a.
I or I equals. It depends on the.
Now this gives me a tuple. This gives me a tuple because you see there are brackets. Now first these entries are the eigenvalues and these are the eigenvectors. This is the eigenvector. This column is the eigenvector corresponding to the first eigenvalue. This is the second eigenvector corresponding to this eigenvalue, and this is the third eigenvector corresponding to this eigenvalue. And they are normalized. So finding these things are that easy. Okay. Now I'll be discussing something completely different. So for example, I am going to discuss curve fitting. Let us see that I have, let's see first, hash everything. Okay, now it is not necessary. So I have a file somewhere, it's data to fit. I want to read this file. I extract X and Y and plot this. Just do that first. Reduce it a bit. So the file is, the graph is visible. Clearly, it tells me that there is, it looks like that it can be fitted with a straight line. Now the point is, how do I fit it with a straight line? And a straight line has an equation, y equal to mx plus c. My aim is to find out, fit it with a mx equal, find out the straight line, or find out the m and c. If I vary m and c, I'll get different straight lines. So I'll find out that straight line which describes this data best. By the method is least square method, and I'll find out that m and c. That is my aim. Now the thing to do is that for that, from scipy I'll import scipy.optimize. From scipy.optimize, I import a function called curve fit, and curve fit tells me that this is my x data, this is my y data, and fit a function ff to this. For that, I have to define a function. What is my ff function? So I've defined the function. So again, say this is my x data, this is my y data. I want to fit this with some function ff. And what is ff? I've defined this. Ff is, say, y equal to mx plus c. Now this m and c are the parameters of this fit. So it will try to find out different values of m and c, and those values of m and c for which the error is minimum, the deviation error is minimum, will report us that. And it gives me a tuple. I unpack that in two parts. One is MC and one is ST. What is that? I'll show you. First of all, what is MC? MC is an array which gives me two numbers. What numbers are there? These are the numbers of M and C in this order. If I give 3 or 4 or 5 parameters, they will show me 3 or 4 or 5 parameters. So the in order in which I have defined them in the f function, in the defining function, they will appear here. So therefore, the value of M is 5.14 and value of C is this. This is as simple. And I'll come to ST later on. So what is plot? Let's see. How does the plot look like? So the original points x and y I plot with blue or circles, and then the point is the x and the fitted function. For the fitted function, I have to give x and also give the value of m and c. Now m and c values are there in the in this array. I could find out m0 equal to the optimal value of m. C0 is the MC0. I could just write here. I could say that M optimal equal to MC0. Yeah, MC0, and C optimal equal to this 0 equal to MC 1. That's the usual trick, so that I know what is the optimal value of M and optimal value of C. And in this, here, I have to get call the function FF with the optimal value of M and the optimal value of C. So I should have given here X, M optimal, C optimal. I can always do that. There is no harm if I do that. But on the other hand, Python gives me another trick, that is star MC. Star MC means if you have a tuple over here, then just unpack the tuple. Unpack the tuple. So MC is a tuple that is array. It's unpacked. Array. It's unpacked. Unpacked. So the components will be just put over there. Just open the packet. Put the things there. So I don't have to really do these things. These are not necessary. I can just say star MC, so value of M and the value of C will go in the proper places and show me what is the optimal curve. Here it is. It looks like that I've been able to find out a good fit. Now, statisticians won't be satisfied. I'm not very good at statistics. I don't know much about statistics, but I've learned a formula. That is, first of all, what is ST? ST tells me just run ST. ST gives me a 2x2 matrix. Why 2x2? Because I have two parameters. Now these things, this is the variance of the parameter 1, and this is the variance of the parameter 2, and these are the correlations of this parameter 1 and 2. Now I know not much about statistics. People usually tell that, okay, you have determined that your aim is this and your C is this. What is your confidence about this? So people usually talk about some confidence interval, that in 95% confidence interval, what is the value of M? M plus minus what? If you are 95, want to be 95% confident, or if you want to be 99% confident, then what should be the value of the parameter 5 plus 1 plus minus 1? Now I've learned that the corresponding formula is this: the parameter estimate that you have got plus minus T into sigma by root n, where sigma is this sigma, the standard deviations. These are the variance. So square root of this is the standard deviation, and root n is the number of data points that you have, and T you have to find out from your degree of freedom. Here I have 100 data points, so degree of freedom is 99, and I want to be 95% confident. So the P one side, I have to calculate the error probability. One-sided error probability is 0.025. So if I consult a table, then T comes out to be this. So I put it here, and doing everything, it comes out that my confidence interval is therefore this. That means my parameter value is 5.14 plus minus this, and this C is this plus minus this. So that's it. That is about a linear fit. So let me show you another example from a non-linear fit. Say this, nothing new. It will be exactly the same thing. Just show you another example. So first, okay, I read our data. I extract x2 and y2 and plot the data first. Did I run this? Yeah. I have to reduce this. No, definitely it is not a linear function. So it's clearly a curvature, and anybody would like to fit it with an exponential function. So let me try this out. The same technique, the curve fit. The same technique. Here, same technique here, curve fit. My data are now called x2 and y2. So I want to fit x2 and y2 with a function f2, and I've defined f2 to be a function which is equal to a into e to the power minus bx plus. So it's an exponential falling function. I'm not sure about the normalization, therefore I kept a over there, and then I gave the did a fitting, and the parameters are in the ABC. So I see, first of all, some values of the parameters, and I want to see the figures. I mean, how it looks like. See, I applied the same trick. First of all, 0K means 0 and black. So my x2, y2 will be plotted in 0 and black, and then this will be plotted in red line, and then I once again use this star convention. So this is something like this. See, it's reasonably good. Yeah, reasonably good fit. It looks like that the fit is okay. And these are the standard deviations of confidence interval, etc. Now, let me show a third example. Let me show a third example. This is what? This is a okay. So it contains 20,000 data in a single row, one-dimensional 20,000 data. And Abhijit has showed us how to do the histogram of this. But only thing Abhijit didn't tell us that this is the thing that Abhijit has told us that this is known for us, that plt.hist. But I can store in the left-hand side some quantities, C, B, P, of which the C and B are very important. C is the count in a histogram. Let me draw the histogram first, then. Yeah, this is the histogram. This is the histogram, it's okay. And now I can explain what CBs are. C's are the counts, the heights. In every bin, the heights are in C. And what are B? B's are the bin boundaries. That is this value and this value, this value and this value, this value and this value. The bin boundaries are there, right? So, so I want to fit this. I want to say this is one of my experimental results, and it looks like that it's a normal Gaussian distribution kind of thing. And I want to estimate the mean and the standard deviation. This is my experimental result. So I want to find out the value of the mean and the standard deviation, right? So first. This is the mean and the standard deviation, and what I have to do, I have to fit a curve to this. Now, first of all, these are the bin boundaries. I want to assign these C's, the counts, with the bin centers. So I have to find the bin centers first, and that is easy. With Python, if I know the bin boundaries, I take, this is, what is this? It's a shifted one. So this one is from the first bin boundary to last but one, and this is the second bin boundary to the last. So if I take the average of them, I actually get the bin centers. So these are the bin centers. So these are the bin centers I've already got, and C is the count. So I have to plot this, fit this bin center versus count with a function. Okay, so I once again call this bin center versus count, and my function is I thought that it will be a kind of Gaussian distribution. So I tried a Gaussian distribution. I don't know whether it's visible. I make it slightly bigger. So this is my curve fit, bin center versus C, and my function is this, which is a Gaussian function, which once again I don't know whether it is a normalization for, I just kept one, and this is, mu should be the center of the Gaussian, and this is a sigma. So I have 3 parameters here. I run this program, and after I run, I get the parameters over here. So let us first hash this one. and see whether my program runs, and then I'll talk about later. So let's just do this. Apparently runs, params, gives me the parameters. It says that the mean is somewhere at 9.97 and sigma is 3.06 and A is 6.09 into 10 to the power 3. Okay, that's good. Now let us plot the graph. Now plotting the graph, I do a trick. Like a BCC, I plot BCC, and there are only 10s because I did a histogram with only 10 bins, So there will be only 10 points for BC and C. But this is a function we know. That's a continuous curve. We can plot as many points as we like using this function, right? So I generate a list which is XX, which starts from the start of B and the end of B. B0 is the first bin edge. B minus 1 is the last bin edge. So within these two boundaries, I generate 1,000 points, and over these XX, I call Fn function. Fn function is this function with the optimal parameters, and do it with a red line. So see what it is. Quite satisfactory. It tells me that it is really maybe a Gaussian distribution from which my samples were taken. So that is what I wanted to tell. This is where I want to stop now.
Any questions or comments? Please unmute your microphone and ask questions.
Sanjay Chattopadhyay made a comment that I think theoretical understanding and experimental curve fitting helps each other to understand the subject better. Definitely, definitely. Without understanding the theory, it's of no use to do the curve fitting. Definitely.
It was the answer to Anish's question before that.
No, the point is sometimes you have to just blind guess because there may be no theoretical framework available. So sometimes you work backwards. That is, you first see if a curve really fits well, then you try to explain why that curve fits well.
There are in statistical methods, like, for example, you can see a decay curve and whether it is better fitted by a single exponential or sum of two exponential. There are statistical methods to establish that. You do the fitting and then play with the parameters, and then you establish that which one is more significant. There are many methods of doing that. Sometimes you really have to do that. How many components you get.
So in physics, usually you always have some theoretical understanding first, but that doesn't always work.
Yeah, for example, in biophysics, I used
biophysics, it almost always doesn't work.
One of my problem that ion channel dynamics, I can see the decay curve, but how many states are there? I mean, this was one of the way to explore how many exponential it is fitted best with. That was one of the ways to do that.
Yeah, in principle, you can fit with polynomial. Any polynomial, you can fit even an elephant, but that is dangerous.
Right.
Yeah, trying to fit higher and higher order polynomials with more data usually is very bad.
And
usually is bad.
Parameters also, then also you can have multiple optimal, and you can fit many things. And that is my, one of the main objection about the Gautam Menon group's work on COVID-19, that they have so many parameters to fit one single curve that I hardly believe this.
Yeah, it's more than 3 parameter fitting of a curve is really dangerous. I have tried it by myself. It can take you to some other directions.
Right.
Anything it can happen.
You can have multiple minimas.
Up to 3 parameter you can even control, keeping one fixed and vary other 2 and so on. But more than 3, it is really dangerous.
But of course, this is not a discussion on the techniques of curve fitting. It was only on the Python. How does Python help you to do the curve fitting?
I think there was a question about can we draw high histogram and curve fitting together in a figure?
Yeah,
I think
of
you
course
showed
can
that,
do.
didn't you?
Of course you can do.
You showed that, right?
Arunabha, you
I
show
didn't
the
show, but that is not difficult.
both things. You on top of it, you also plot the histogram. That will
Okay,
satisfy the question.
You already did that, right? You can also
No, I
plot
didn't
the
do
histogram
that.
along with it.
Do that.
Along with it.
Achha. Let me see. This line was
The
this.
histogram, just another plot on this curve fitted curve.
Let me see.
Copy and paste and
Let me just
side by
try
side.
this. Huh?
Side
Just
copy.
copy this, and the last line. This was this. Last line. Let me copy. Because I don't allow any new figure, I believe that they will be superposed on each other.
Yeah, you have not drawn
I
anything.
think
Done
we'll do. I
anything.
think we'll do.
So, because I'm not allowing new figure, so these two will be superposed on each other, I
Yes,
believe.
it will do.
Yeah.
Yes, that's it. Correct. Yeah.
Any more questions? We have.
Sir, I
10
have a
minutes.
question.
Yes,
Of
please.
course.
Can
If
you-
know who you are, I mean, every day I hear your voice, but I know who you are. I mean, please, your name, please.
Okay, I am Ritu Priyo.
Every day you ask question. I'm familiar with your voice.
Okay. Can you please revisit your ST? I mean, in your code ST part.
This is my Achilles heel. Don't ask me tough questions because I don't know much about it. I can just tell you that this ST, this contains the, for example, okay, let's go to the 2x2 system, right?
Yeah.
Yeah. These, in this problem, I have two parameters, M and C. And this
Okay.
ST tells me the variance of this ST and the variance of C and this, and the correlations of these two.
So that's what the return value of the curve fit function.
Return value of the ST function. I mean, this
The curve fit function returns two things.
function gives me two values. One is the
Yeah.
optimized parameters. The other
Yeah.
one is the statistical parameters. Yeah.
Okay.
It returns two arrays. One is the
arrays, yeah.
array with parameters, the other is the array with
I
the
just unpack them
deviation.
itself.
Okay.
The covariance array.
Yeah. Usually,
And-
the tutorials they say P opt and P cov. I've given them two names, MC and ST.
Okay. And in a general curve fitting case, then we have to guess some function. I mean, some
Right,
good guessing,
right.
and then we have to define it with suitable parameters, and the curve fit function will return the best fitting parameters.
Right. And also, in Python 3, it gives you many utilities. Like, first of all, you can initialize the parameter. If you have some sort of guess, what should be the value of the parameters near about, so you can initialize the parameters, and also you can provide bounds that this parameter will be within this value, this parameter will be within this value. You can specify that sort of constraint. You can constrain them. That also can be done. In fact, I did that for my some sort of fitting that I will discuss you with Monday.
Okay. Okay, sir. Thank you.
Okay, thank you.
Sir, I have a question.
Yes.
Yeah, please.
So suppose I don't have to feed the entire data file, but rather I need to find out the slope at some particular x value.
Yeah.
So for that, how can I feed the?
At some x value is a difficult problem because you are actually it's a regression problem. You have to have some a few amount of data through which you are passing the curve, not exactly doing a tangent kind of a thing, right? So you have to have
Right.
at least a few number
No,
of points.
suppose
But you can actually take
No,
a
suppose,
slice of the data and just fit it in a small
Right, sir.
region. You
Sorry,
can fit it in a
Ananda,
small
what
Exactly.
is your
region.
answer?
That's
Ananda, please repeat the answer. I missed your answer.
No. The point is you don't. I guess what he's
Slice
trying
the
to do
data.
is that you can slice up the data,
Right,
take a
right.
small
That's
slice,
Exactly, sir.
clear the region which you want,
yeah.
and
That is
then
once
fit a
again.
straight line there. Instead of
Once
fitting
again, Monday, if I get a chance, I'll show you that I've sliced the data and fitted that with in the initial part I get a fit, from the later part I get another fit, and I compare them. These things I'll show you on Monday if I get a chance. Yeah, slicing of the data and fit.
So on what Anando sir has said, that can I specify a particular X range within which
Yeah, of
the
course.
data will be
No,
fitted?
well,
that's
actually,
easy to find.
specifying an X range would be difficult directly. It would be easier to specify. Suppose you
See,
know where that X data is,
for
especially if your X
example,
data is in order.
in this particular case, for example, instead of giving the whole x and the whole y, you can just within this fashion, you can sorry within this fashion, you can just say this to this and this to this, right? So if I always slice x and slice y and ask it to fit.
So that will not really be the X range. It will simply be the order in which the data appears in your arrays. If X is already ordered, which usually it is, then it's straightforward. If X is not ordered, then it takes a bit more work to first produce an piece which for that only those X's which are in that interval and so on. You have to write a line of code for that.
Line of code for that.
Okay. No, I am talking for order data only. So in that case, giving the range within the third bracket.
No, suppose the X value you want, say it's 2.7, and that's say the 275th element of your array. Then you can go say 275 plus minus 20 on both sides and fit a straight line there.
Right.
Yeah.
So the same function that sir has written over here, that define ff, return mc plus mx.
Yeah, that's a straight
plus
line function. You want just a slope, then you have to fit a straight line.
See, in this example,
I'm fitting with a straight line.
In this example, I've fitted an exponential function, and in this example, I've fitted a Gaussian function.
So I can provide the X range within which I am I'm trying to fit the curve.
Because all you are giving are two arrays of X and Y values, right? So even instead of giving the whole arrays, you can give pieces of the arrays.
Okay.
As long as they are both the same length, right? You don't want to mix up that. That's important.
Okay. Right, sir. Understood. And since one more thing, sir, a small thing that suppose I have a very complicated data file. So instead of providing a user-defined function, because Python is coming up with a huge library, so instead of giving a user-defined function, is it possible to ask Python to approximate some function to fit the data file?
Well, actually, that's a machine learning question more than anything else.
Right.
Yeah, because that's exactly what machine learning programs do.
Yeah.
Okay, that's one of the things which machine learning does, and you can of course implement that in many languages, including Python. Python has wonderful libraries for that.
Right.
Right, sir. That's what I'm asking.
Yeah, that can be done. Whether that the point is, if you're doing this in a science problem,
I didn't get it. You want is this question? I mean, your
the question would be:
was
can you guess the function?
Is it?
That is, can you make Python guess the function?
Right, sir.
Well, that's possible. That depends. You have to give some criterion as to when you consider a guess good. And there are many, say, genetic algorithms. This is nothing to do with Python. This is basically a standard machine learning task in computer science, which is very prominent nowadays. However, well, that depends on whether you believe in a function which the computer comes up with. Well, for example, if somebody wants to write a function which describes the number 9 as written by somebody by hand, that would be almost impossible because people write differently, right? But essentially, what the machine learning problem for recognizing numbers handwritten digits, for example, essentially boils down to finding a function somehow. That function may end up being very complicated, but you don't care because the computer, if you feed it to the computer will give you the answer immediately. Now,
Right.
on the other hand, in many scientific tasks, it's important not to have a wonderfully good fit to the data just by some arbitrary function, but to understand why the function is the way it is. And there, of course, using blind machine learning may be bad. You end up with a very complicated function which means nothing to anybody. After all, part of science is not only to describe, it's also to understand.
In machine learning also, you try to avoid overgeneralization, right?
Yeah, of course. You constrain it as much as possible because, but
That
the
is why
point
you
is the kind of generalization people do in machine learning is way too much for, say, people who are used to doing analytical science. But still, it's very highly constrained. You don't allow everything under the sun. Then it will be completely senseless.
Right.
We have no time left for this session. It's just 6 p.m. And
so we will meet day after tomorrow, right? Tomorrow
yes,
is
it's
a rest
day
day.
after tomorrow. We'll be back on
tomorrow. I
Monday.
don't have to show many. I'll just show my playing with some numbers. It's easy for me. Thank you.
Okay. Thank you all. Thank you.